Hi, I'm Dr. Kiki Sanford, and today on Food Science, we're going to show you what steak, coffee beans, caramel, and toast have in common. So what do steak, coffee beans, caramel, and toast have in common anyway? They all gain special odors and flavors when they're cooked because of a special process called non-enzymatic browning. There are two kinds of non-enzymatic browning reactions that take place because of the sugars, caramelization and the Maillard reaction. Caramelization is the interaction of sugars with sugars, but the Maillard reaction is the interaction of sugars with amino acids. The most basic caramelization in the kitchen is the melting of sugar into a syrup. It's easiest to caramelize sugar if you use water. The water allows more even heating of the sugar, it reduces the possibility of it burning, and it also helps out the chemical reactions that are taking place. Give it a little mix. White table sugar is made up of sucrose. It gets broken down into fructose and glucose when heat is added. You need to cook it at 170 degrees Celsius for caramelization to take place. Fructose and glucose are reducing sugars. That means that they give some of their electrons to other molecules. As they break apart into smaller components due to heating, their tendency to donate electrons leads to totally new compounds. Some of the compounds give the developing caramel its color, while others deliver its flavor or aromas. Diacetyl gives off a buttery flavor. Furan is nutty, and acetaldehyde lends a rum or a sherry component. Caramelization, in addition to requiring heat to get started, actually produces heat as it develops. The chemical reactions are thermogenic in nature. So it's probably a good idea to keep an eye on the temperature of your caramel so you don't end up with something all bitter and burned to the bottom of your pan. But what about other kinds of foods? You've probably heard of or even tried caramelizing onions at one point or another. The truth is that caramelization does take place. This onion is full of sugars, but it also contains amino acids, which means that the Maillard reaction should take some blame. When heat is added to the onion, the carbohydrates in its cells start breaking down. The carbonyl group, that's carbon atoms double bonded to oxygen, start binding with the amino groups of the amino acids. And then you get caramelization plus the Maillard reaction, and it's masses of Maillard caramel fun. When you sear a steak, it doesn't seal in the juices. The Maillard reaction is responsible for making it taste better. The high heat causes amino acids in the surface of the muscle to form new compounds with carbonyl groups in the carbohydrates and other compounds in the muscle. Because of caramelization and the Maillard reaction, new compounds are formed which are responsible for the delicious flavors and odors of seared steak, caramelized onions, and even toasted bread. But remember, it's not just food, it's science. What is it? It's science. I don't know. What is it? It's science.